Good day, grade 11s. Today we are going to be looking for an angle that will make an identity undefined or an equation. So in general, a mathematical fraction is undefined when the denominator is 0. So that's what we are going to use even today. So if you are given an equation, that equation is going to be, or that identity is going to be undefined if the denominator is equals to 0. Okay, so we've got two cases. Case number one, where just defined by the denominator, which is equals to 0. An example is this one, where we've got 1 plus 2 sine theta cos theta over sine theta plus cos theta, which is equals to this. So this is an identity. This is something that you would have been asked to prove. Could see this is equal to that, but now that's not what we are doing. So this is going to be undefined if this denominator is equals to 0. So the only thing that you do is just equate the denominator and you equate it to 0, which is what I have done. Then you solve for theta. So you make an equation at the bottom, by equating the denominator to 0. And then you solve the equation. So this is, you divide by cos on both sides, because now since we've got sine and cos, it means that we are going to have tan. So it becomes tan theta, which is equals to -1. So that means the reference angle, which is in quadrant 1, is going to be 45. And then theta number 2, where sine is, where tan is negative, is then going to be 135 plus k times 180, where k is an integer. Okay, so that's the first general solution here. And then your second general solution is then going to be 315 in the fourth quadrant, where tan is negative again. Right, case number 2 that we have is the case where, the cases that involve tan. Okay, so if we look at the graph of tan, the graph of tan looks like that. We know that the period for tan is 180. Now, the graph looks like that, where it has a vertical asymptote at 90 and a vertical asymptote at 270. So this value here is 90, where there's the vertical asymptote, this one is 90. So that means the graph doesn't touch. Whenever you put tan 90 in your calculator, it will give you error. And the reason for that is that we've got this vertical asymptote, and we've got another vertical asymptote at 270. So the second case is that whenever your equation involves tan, then we know that the graph is going to be, or that equation is going to be undefined at 90. The graph is going to be undefined at 90. So that means if your equation involves tan, there's no calculation that needs to happen. You just write this is going to be undefined if theta is going to be 90 plus k times 180. So now this takes care of the other asymptotes. Now if you can check, 90 plus 180 will give you 270, which is the next asymptote. So it is covered over there. And then again, the next asymptote will happen after 180 degrees. So all the asymptotes are taken care of by the k times 180. So whenever the identity or the equation involves tan, and you're asked for the place where it is going to be undefined, it will be undefined where? At 90 degrees. Okay. So now let's look at this next example. If you check here, we've got a fraction here, a fraction there, and a fraction there. And we have tan. So before you can even carry on and calculate the equations that will come from the denominators, because we have tan, you can simply conclude that it will be undefined at 90 plus k times 180. Okay, which is what I have done. That's the first answer that I will have. Then I carry on. I will say it will be also undefined if 1 minus sine theta is equals to 0, which when I solve gives me 90. And yeah, it gives me 90 because 90 from the first x and 90 again from the second x. So I only have 90. And then the second one would be, it will be undefined if 1 plus sine x is equals to 0, which then gives me -1. And then my reference angle is going to be 90, which then gives me 270 in both cases. Okay, and then the last one would happen if cos x is equals to 0. You'll see what I've written or because it could be this fraction that causes it to be undefined, or this fraction that causes it to be undefined, or that fraction that causes it to be undefined. So this one gives me 90 and 270. Now you will notice that 90 appears how many times? 1, 2, 3 times. And then 270 appears 1, 2 times, and this is exactly the same as that. So that means I'm going to write that only once. And then now I've got 90 plus k times 180 and 90 plus k times 360. Now again, this is one solution. I just want to explain why this and that. If you notice, if k here is equals to 2, it is going to be equals to it is going to be equal to 360, this, which is the same as when k is equals to 1 here. So 90 plus 360 is taken care of by this one when k is equals to 2. And then 90 plus 720, that will come if k is equals to 2 here, will be taken care of when k is equals to 4 here. So that means this solution and this solution is the same thing. So I'm going to write it once. So I'll write the one, that one that has 180, because the one that says 360 is taken care of within this, when I now introduce the case to write my answer. So that is why I've only just written the two answers. Okay, I hope that is clear. Please do exercise 14, number 1A and number 2.